Welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 3, RK Bali navigation book. This is the 4th edition book. If you have any other edition book like the 5th one, the 6th one or the 7th one, no issues. The questions in that books will also remain the same as the questions in this book. So now let's begin with a new question, question 41. At which minimum height will the second line segment end? It will end second line segment. So look at this diagram, look at this picture. So your first segment starts when you are 35 feet above the ground to the point where you retract your landing gear. That is your first takeoff segment. The second segment starts from the moment you retract your gear to the point where you reach 400 feet minimum altitude. Minimum 400 feet altitude. That is the end of your second segment, where the point where you reach 400 feet minimum altitude. Right? So at which minimum height will the climb segment end? Minimum 1500 feet above elevation, field elevation, 35 feet above ground, 400 feet above field elevation. So the correct answer here will be 400 feet above the field elevation. Okay, that is your second segment. Next, option Charlie. It's very important that you understand this takeoff line segment. It is very important for your airline interviews, ATPL Viva exam. Okay, next. The radio wave covers in 1 microsecond a distance of what? So, 1 microsecond is equal to 300 meters. Remember. So, option A. Now, if you want to calculate distance, distance is equal to speed into time. So 3 into 10 raised to 8 meter per second. Time is 1 microsecond. So 1 into 10 raised to minus 6 seconds. So 3 into 10 raised to 2 meters, which is nothing but 300 meter. Okay, simple. For a flight plan filed before the flight, the indicated time of departure is the time of takeoff, the time at which the flight plan is filed, the estimated off block time. So correct answer is option Charlie. The time that you file in your flight plan, that you write in your flight plan, that departure time is nothing but estimated off block time. It's not the accurate time, it's estimated off block time. What is estimated off block time? The time you expect to leave the parking gate, okay, parking area, parking gate, and start your taxi towards the runway. That is your estimated off block time. Next, aircraft flies a great circle track from 56° north 70 west to 62° north 110 east. The total distance is equal to how much? Now look at the longitude, 70° west 110° east. The addition is equal to 180°. That means these points, point A, departure and destination, are located on meridian and anti-meridian respectively. So meridian and anti-meridian together form a great circle. So your aeroplane is going to fly this great circle through the North Pole since you are in the northern hemisphere. So let's draw the Earth diagram. North Pole. This is the view of the Earth from the North Pole. 180 east and west, 90 east, 90 west. Okay. 70° west will be somewhere here. Point A. Point B, 110° east will be somewhere here. So you can see both are amne samne, both are directly opposite to each other. So the great circle track will look something like this. You will fly towards the North Pole. This is your departure point. You will start flying northerly direction, cross the North Pole, and then start flying southerly direction towards your destination. So this is your great circle track. This is your great circle track. So now we will draw another diagram for latitudes. This is your northern hemisphere. You have 90-degree North Pole, 56 North, 70 West. So 56 North, 70 West, 62 North, 110 East. So total distance between them is equal to how much? So distance is equal to d lat or just let's just write distance between them will be equal to difference in latitude between North Pole and 56-degree North, 90 minus 56, plus difference between North Pole and 62-degree North. So 90 minus 56 is 34 degree plus 90 minus 62 is 28 degree. So d lat is equal to 62 degrees. D lat equals to 62 degrees. Okay. So great circle distance will be d lat multiplied by 60. So 62 degree multiplied by 60 equals to 3720 nautical miles. 3720 nautical miles. Option alpha. 45. On 27th February at 52 degrees south, 40 degree east, the sunrise is at 0243 UTC. On the same day, at same latitude, but 35 degree west longitude, the sunrise will be at what time? Okay. So this is the representation of the earth. This is your prime meridian, 0 degree, where UTC time is kept. The first longitude is 40 degree east. Second longitude is 35 west. Now the sunrise time at 40 degree east is 0243. Is 0243. What will be the sunrise time at 35 degree west? Now western longitudes are behind in time compared to their eastern longitudes. So if sunrise happens at 0243 at 40, on 40 degree east longitude, so at 35 degree west longitude, the sunrise will happen later, much later. So how to determine that? Now, uh, time at 35 degree west longitude equals to longitude will be sunrise time at 40 degree east longitude plus the time difference between those two longitudes. If sunrise happens in the morning 02 hours 43 minutes at 40 degree east longitude, it will happen much later at 35 degree west longitude because the timings at 35 degree west longitude are running behind in time. Okay, so 0243 D long between them is 4075 divided by 15. So 0243 plus 75 divided by 15 is equal to 5 hours. So that is equal to 0743. So sunrise will happen at 0743 at 35 degree west longitude. Magnetic heading, magnetic variation, drift is given. What is track? So what is true track? So if magnetic heading is 060, variation is 8 degree west. So variation west, magnetic is west, meaning magnetic direction more than true direction. So true direction, that is true heading, will be magnetic heading minus variation, minus variation. 060 minus 8, 072. So true heading is equal to 072. Now drift is 4° right. Drift is 4° right. So starboard drift, whenever you have a starboard drift, heading is less than track. Now heading drift is 4° right. Heading is 072. So track will be more than 072. So track will be 072 plus 4, that is 076. 70 plus 4. Heading is less than track. Heading is 072. So 060 minus 8 is 052. Correct that. And heading is 052. So 052 plus 4 is 056. So correct answer is option Bravo, 056. Course given, task given, wind speed is given. What is the maximum drift angle that will be obtained for a wind direction? So maximum drift angle, that means angle equals to 90°. Maximum drift angle, that means complete crosswind at 90° or perpendicular to your track. Correct? So course is 040. Okay. Course is 040. With a course of 040, maximum drift angle will be obtained from a wind direction coming at perpendicular to the track. So 040 plus 90 is equal to 130. So the wind should come from either a direction of 130 or 40 minus 90 plus 360, a direction of 310. So if the wind is coming from either direction, you will get maximum drift angle, maximum crosswind. So, so of the three options, 130, 145, 115, 130 will be the correct answer. 48. The distance between two waypoints is given. The compass heading, to calculate compass heading, pilot uses 2° east variation instead of 2° west. Assuming that the forecast winds apply, what will the off-track distance be at the second waypoint? Okay. So what is the error? The magnitude of error here is 4°, 2° east and 2° west. The magnitude of error is 4°. Correct? So let's draw this diagram. So 4° is the magnitude of error. Horizontal distance is 200 nautical miles. To find out off-track distance. So 4° track error angle equals to off-track distance divided by 200 into 60. So off-track distance will be 200 multiplied by 4 divided by 60. So 200 multiplied by 4 divided by 60 is equal to 13.3 nautical mile. So you will be off track by a distance of approximately 14 nautical miles. 49. In a non-pressurized aircraft, if one or several static pressure ports are damaged, there is an ultimate emergency means for restoring a practically correct static pressure intake. So you're flying a non-pressurized aircraft, let's say Cessna 172, Cessna 152, okay, and the static ports, static holes, the entries are blocked or damaged. So there is no way through which outside static pressure can enter your airspeed instrument or your pressure instruments. So is there any other alternative way you can use, alternative way to restore the static pressure or to retrieve the static pressure from outside? Yes, you can break the glass of vertical speed indicator. When you break the glass of vertical speed indicator, whatever pressure is in the cabin, okay, since it's a non-pressurized aircraft, the pressure in the cabin, in the cockpit will be more or less equal to the pressure outside it. So whatever pressure in the cabin, that pressure will enter the pressure instruments and your pressure instruments will work. Okay, will work using that static pressure in your cabin. So the emergency situation, the last solution is breaking the rate of climb indicator glass window, slightly opening slightly opening a window to restore ambient pressure, no, descending as much as possible in order to fly at a pressure as close to 1013, no. So option alpha. The altimeter consists of one or several aneroid capsules located in a sealed case. The pressures in the capsule, so the pressure in the aneroid capsule is vacuum, and the pressure surrounding the vacuum aneroid capsule in the casing is static pressure. That is static pressure. So let's say this is your altimeter instrument case. Okay, this is the aneroid capsule. So this is your aneroid capsule. This aneroid capsule will respond to the static pressure that is coming from the static port. Okay, this static pressure will surround this aneroid capsule, and inside this aneroid capsule there will be vacuum. There will be vacuum. There will be vacuum. Okay, so this concludes our lecture. I hope you have understood all the 10 questions I have done in this video lecture. Best of luck. I request you all to share this video, this particular channel with your friends who are also preparing for the exam. They might find this channel very useful. If you have liked this video lecture, do hit the like button and subscribe to this channel if you haven't yet. Best of luck. See you in my next video.